Hello. In this Cisco networking web series, I just want to let you know about this dynamic protocol, which is EIGRP, which is very important and widely used across the industry. And also, this is a proprietary Cisco's protocol. EIGRP is widely used in Cisco routers. So even though we have various kind of routing protocols, we use this because of enhanced support. Enhanced, it gives a maximum performance for this and less what we call as the bandwidth wastage. So compared to RIP, this is so in RIP the big disadvantage is it cannot cross beyond 16 routers. 15 routers is the maximum, 16,000 is unreachable. So it is good for limited, not for large and complex networks. Whereas this EIGRP can hold up to 255 hops, whereas by default it is 100, but you can go up to 255 hops. So that is one big advantage. So that is the reason why we use for larger networks. And also second advantage is it has a reduced bandwidth wastage. Like we most of the time we waste on administrative distance like 120 in RIP by sending the packets which are routing packets every 30 seconds. But here it's not like that. The algorithm is not distance vector. It has dual. It has dual. Dual means diffused update algorithm. So it's a mix of two algorithms. One is distance vector and the other is link state. So I'll be introducing both these algorithms in this presentation. Okay. So what it does is that like these are the biggest advantages. So that is the reason why we use this Cisco's EIGRP. Like if I try to explain about how EIGRP really works, because since it can handle a large in the enterprise, okay, so it is distinguished how to identify almost all. So we have a specific what we call as an autonomous system. Autonomous system is a group of routers which can hold in a particular location or a zone or a department or something like that, not department, within a particular area or something like that. So what it is easy for troubleshooting and also it is easy for communication. So autonomous system 1, autonomous system 2, like that you can have multiple autonomous systems. Every autonomous system has a number which can be recognized. So same thing, when a packet from one router needs to transfer to another autonomous system, naturally the border gateway protocol, BGP we say, will really work across. It transmits from one IGP to another EGP. So within the EGP communication we call as interior gateway routing protocol, IGP, interior gateway protocol. And if it is anything which is exterior to autonomous system 1 for autonomous system, it is called as exterior gateway protocol. So in this way, the complexity of the routing locations or the areas is reduced. Suppose if router A in one of the IGP is not able to communicate to a router in some other administrative autonomous system, so what we can generally do from this router, whether it is able to go to the border. If it is able to reach the border, then okay, then then all these routers may not even communicate to other areas. So the border needs to be troubleshooted. If they are able to if they are not able to communicate between interior also, then there is not a problem with the border. So it needs to be troubleshooted accordingly. So here in this way, the troubleshooting can be easily taken and performance is highly rated. So here as I mentioned that the maximum hop count is 255, reduced network overhead, improved convergence time. These are all the biggest benefits of EIGRP. IGRP is like the version 1 of RIP, which doesn't communicate the subnet mask. It can hold only what we call as classful networks. Whereas in EIGRP, we can even communicate classless, where it is independent of CIDR. Here, the CIDR should be same for all the networks. Otherwise, there is no communication. And there are more improvements also which has been taken in EIGRP. That's why we call it enhanced. Both of them are Cisco's protocol only. So here, let me explain about how this dual protocol works. The multicast IP is 224.0.0.10. Like in RIP, we had 224.0.0.9. We have here in 10. So what it does here? So here in EIGRP, as I mentioned that it has a dual protocol. The first one is called as a distance vector. Two protocols will be there. What it does, every 5 seconds, it only just checks the neighbors and sends hello, hi, hi. That's all. No, what we call as routing information. Just say hi. Like we go across the road and we see someone and raise our hand, hi. Same thing here also. Hi means it is an indication that my network neighbors are okay or not. Right. If there is any difference in my neighbors, then immediately I will raise the second one, which is called as a link state. If there is a new neighbor which has been added, off, or if there is a neighbor which is not been recognized, either of these two cases, then it will immediately arise a what we call as a link state algorithm will works. It will immediately broadcast, or it will immediately sends an alert. Okay, it will immediately sends an alert to the neighborhood protocols to update the new neighbors which has been added or link state. This is called as link state algorithm. So with the help of this, each and every router gets updated whenever there is change in link. Okay, in this way there is a reduced what we call as the bandwidth wastage. So that's why we call as this as EIGRP, enhanced interior gateway routing protocol. So here, like as I mentioned that there is a neighboring table, there is a topology table, there is again a routing table. A routing table basically defines about what are all the routes, discovered routes. This is the endpoint. Neighboring table is discovery of your neighbors or your what we call your next routers which are there. Topology table will be defined once you have all the network updates happen across. I mean the routing updates happen. This topology table will take care. A feasible successor is a backup route and stored in the topology table. So how do we do this configuring the EIGRP routers? Like you can select one of the AS within our autonomous system and just specify router EIGRP with autonomous system number and define your connected networks. That's all. Rest of the things it will take care. As I mentioned that this can enhance up to 100 as default but 255 hops. So it can go across any part of the globe more or less. Okay, so that is these are some of the commands which we need to perform. So let me start how you can do on my lab exercise. So I'm opening these three routers. Okay, so what I'm going to do is go to CLI. Okay, EN. Show IP protocol. I don't have anything. I just want to show you. Show IP protocol, nothing. And also show startup. You can see show startup config should not define any protocol information. You can see there is nothing. Interface only IP address are configured. Nothing more. There is no protocol defined. Okay, so now let me configure this EIGRP protocol. Conf t. Okay, I can say router EIGRP with autonomous number. I'll get 10. That's okay. Network 192.168.1.0 and I can give my 2.0 also and write memory. Done. Similarly, I can configure for London and Singapore router also. EN router EIGRP 10 and network 192.168 2.0 3.0 and 4. See, automatically it has discovered this one. There is a new adjacency. Okay, 3.0 no 3.0 and 4.0. 2, 3, 4 are the connected networks for this London router. Oh, sorry. We need to do write memory. Oh, sorry. Okay, so it has written. So similarly for Singapore. EN EIGRP router EIGRP. I can say 10. Give all routers same autonomous number. Don't change. Otherwise, it will be going in sitting in a different network. And we have to do intra autonomous system configurations. Okay. So that is again a different one. So network 192.168.4.0. It has discovered now the decent one through the serial interface. Okay. So and right, done. So now once the routes are done in all, I can say from here I can select the terminal and then try to ping 192.168.5.2. Let me see. Yeah, the reply has started. You can even trace the route also. TRS trace route 192.168.5.2. Sorry, trace RT. It shows like a trace RT 5.2. What are all the in between routers? What is the path which has been selected? So from my location to the first one is 1.1, my gateway router, then 2.2, then 4.2, then the final path. So this is how the trace route also can be done. Okay, finally I can save my exercise 3R. And I need to verify some of the things. So I'll show you how you can verify. So these are my verification commands, some of them which we already learned. Show IP protocols and show IP route. Show IP route, EIGRP, show IP EIGRP topology and neighbors, and of course we will be verifying all these things. Okay, right. So yeah, select this one of the router. So show IP route will show you, you can see this one. D stands for dual. D stands for dual of EIGRP. You can see 3, 4, 5 are the discovered routes via so and so. Okay. So this is about show IP route. You can also say show IP protocols. So the protocol which is configured is EIGRP 10. And you can see the administrator distance is 90. Okay. So 90 internal within the IGP is 90 and external is 170. So that is there is a variation. Please remember. Okay. So like also I can say is that maximum path is 4. 4 different paths can be easily identified to reach the destination. Okay. So now show IP EIGRP neighbors. So this particular New Delhi has one router which is called as 2.2 neighbors. In this way we can identify the neighbors. So now I will also show you the next is topology. In this way it has discovered all like 1.0, 2.0, 3, 4, 5. You can see this whether it is active or passive or the interface how it has been distinguished. Okay. Yeah, via connected via so and so. This is about show IP topology. EIGRP. So this is the command. It has mentioned all. It will display the routes EIGRP discovered routes, all the 3 routes which has been discovered. And now I will also show you about show IP EIGRP. That is traffic. Like what you have discovered, it will show you the traffic overall. Hello sent is 155. Again update sent is 4. There are any changes only, then only it will be sent. Otherwise no. So with this, like you can try for the other routers also. These are all the verification commands. So once you have done, you can save this and then. So in my next exercise, I'll be showing about another important what we call as an open source dynamic routing protocol, which is OSPF. Okay, thank you and bye.